All right, another thing we can look at with functions is increasing and decreasing function. A function is increasing where it has positive slope and decreasing where it has negative slope. So if we were looking at this particular graph, where it's increasing would be here, this whole range here from A to B, it's increasing because we can see it slanting up. From B to C here, now we're decreasing because we have negative slope, and then we're back to increasing here from C to D. So that is just using the slope concept you've had before. Let's look at some examples. Approximately what interval is f of x decreasing at? All right, let's use our boundary notation that we've had before. It looks like on this one that from 2 all the way, looks like maybe a little bit past 6 here, so 6.2 or so. I'm just estimating, but somewhere in that range, it's somewhere in that range, it's decreasing. All right, state the domain. Remember, domain is our x values here. So what x values is this on? Looks like it starts right here on the axis. We can see the arrows up here, so that's their axis. So it's starting at 0 and then moving out here to, looks like 7 is where it ends. So domain would be from 0 to 7. And we'd want to include those points because there are points at both 0 and 7. All right, next example, f of 1 equals what? So remember, f of 1 is talking about what's the output value when the input value is 1. So to locate that, what we'd want to do is find where 1 is, follow it up to our graph, and then go over and see what the output value would be. It appears on this one that it would be at 3. So f of 1 equals 3. Once you pause the video and see if you can answer the one at 7. All right, 7 is out here. Looks like that value is right on the axis, so f of 7 would equal 0. Estimate the solution of the equation of f of x equals 3. Remember, f of x is like our y value. So where do we have, what input, this is asking what input values end up with a y value of 3. Well, I think we had one of them already. We know at 1 it is. Looks like there is a second solution out here at 3. It also at x equals 3, it also passes through a y value of 3. So the solutions to this would be x value of 1 and x value of 3 both give a y value answer of 3. Or in other words, both f of 1 equals 3 and f of 3 equals 3. So 1 and 3 would be the two solutions. All right, now let's look at some graphs. What is the domain and range of this graph? So when you start thinking domain, that's our x values. You want to think, start kind of off with the idea that it's every number. Can we put every number in for x in this function? Some functions you can. Other functions you can't. This happens to be one you cannot put every number in for x. Many can. If you put 10 in there, we're good. If we put 6 in there, we're good. If we put 7 in there, we're good. I can figure out what this equals. Square root of, that'd be square root of 9, which equals 3. I can solve that. And it doesn't even have to come out to be a nice number. But there are certain numbers I can't even do on this one. And that would be because of that square root. Remember, can we do square roots of negatives? No. So now we got to figure out what's the smallest possible number we could put in there before that result comes out to be negative. And I think on this one it'd be -2. -2 is the smallest number I can put in there and still do this problem. I can do square root of 0 because that's 0. If I go any smaller than that, for example, -3, now I can't do this because I got square root of negative. There's no real solutions to that. And so for this one, our domain would be all the numbers from -2 bigger. So we'd start with -2 and then go to infinity. And infinity, remember, we always put the parentheses because there's not an exact value for that. Okay, next one, what is the range? That's our y values. That one, a little bit harder to figure out sometimes, but usually on this one, like if you have a smallest value, that smallest value will probably give you one side of that range. So what would we get when we put in -2? Our result comes out to be 0. So my guess is for the range here that our range probably has something to do with 0. And if you put in bigger numbers, your result keeps getting bigger. So my guess is that it's probably going to go 0 on up to answers of infinity. Let's double check that by graphing. So we'll put this function in, and I already got it inserted here, square root of x plus 2. Let's graph and see what we got here. So our domain is, I'm going to change this here. I got a different one. I'm going to use standard graph number 6. Are we starting at -2 for our smallest x value? Yep, and it's going to the right, so we're good there. Our range is our smallest value, 0. On the y-axis, yes, it hits on the y-axis, that's a y of 0, and it goes up, so it would go to infinity. So it looks like we got the correct solutions there. All right, next one, I'm going to have you kind of attempt part of this one. Let's start with domain. Domains are x's again. What's our domain? So you're trying to think, what are the numbers that we cannot put in for x here? And I'll give you a hint, there's 2 of them. So let's see if you can figure out what those 2 values are. Okay, let's check. It's a little bit, you can maybe just guess and check by looking at this. One thing to do is, can we do any factoring here? And it does look like both these have an x. I'm going to factor out an x to help us out here. So what are the 2 numbers x can't be? Well, if we can't have dividing by 0. And so if you put 0 in there, not going to work. If you put 1 in there, not going to work. So the 2 numbers x can't be are 0 and 1. So the domain of this one should be all the numbers except 0 and 1. Any other number is going to work. So how we'd write that? -infinity to 0. 0 to 1 should be okay. Union then again with the numbers from 1 on, because 1 on should work. 1 all the way up to infinity. So that's our domain. Again, range becomes a little bit harder. What's the y values here? So again, let's look at the graph and see if we can figure this one out. So on the graph, let's plug in this one. Make sure whatever's in the denominator here, we need to put in parentheses. All right, and let's graph. And we can see here, there are no values at 1 or 0 here, because there's what's called the asymptote lines there. But we do have values, looks like going up to infinity, and we also got this part on the bottom that looks like it's kind of going down here. So we got this graph that it's kind of looking like this. We got those kind of imaginary lines at both 1 and 0, and then we got our graph going like this and like this, and then there's this piece down here that's going like that. So let's see if we can describe this. What y values do we see? Well, we definitely see the y values here, where this is going to keep going here. It's never going to quite touch 0. So 0 is not included in this. But we do see it keeps going up, so it's going to go up to all the numbers going up to infinity here. So that's part of it. But then we also got this little part down at the bottom here. So we want to include those numbers as well. And since our graph's going to go down, 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 down at those asymptote lines, it's definitely starting at -infinity. But then there's some top point right here we got to figure out. That's the highest it goes. So let's see if we can go back to our graph and figure that out. What's the highest point that gets? One way you can do that on the calculator is that's called a maximum. So you can go to the calculate function. We can go down and select maximum here, number 4. We want to select a point to the left of that. So maybe like, we know 0 is definitely to the left and 1 is to the right. So I'm going to input 1 and let's have our calculator guess. Oh, I guess I can't use 0. Let's try again. We want to do maximum because you can't put 0 in, so I'm going to put something like 1/2. Should work. And on the right, I'm going to put like 1 point, or well, let's not even do, let's do like 0.7, something before 1. See if we can get that maximum. Looks like the maximum is at 1/2, and it is when you get the y value, top y value is -4. So -4 is as high as it goes. So that would be our range. One last example, graph this function, y equals absolute value of x. So let's go on the calculator and do that one again. To find absolute value, go to the math menu, go over to the second category on top by hitting over, and this ABS is absolute value. Some of your calculators might actually put the absolute value sign around this when you do it. That's great. All right, hit graph. So the graph of this one looks like this. We got something like this. And we got the points going here. So there's a hits at 0, 0. There's a point at 1, 1, 2, 2, 3, 3, and so on like this. And it keeps extending out in each direction. That's the graph of absolute value. What's the domain and range of this one? The domain in range 1, should pause the video and see if you can answer that on this one with the picture. All right, let's see what you got. Domain, that one on this one's going to be all numbers. You can put any number you want into the absolute value function and you can get the result. The range on this one, that's our y values. Lowest it gets is 0, and then it keeps going up to infinity. So that would be our range. This is an example of what's called a piecewise function. And it's piecewise because there's actually 2 different functions involved. When x is bigger than 0, on the right side of this graph, this side is the graph y equals x. Slope is 1 and the y-intercept is 0. The other side, though, is different. That's the graph of y equals -x because the slope there is -1. And so it's a different graph when x is less than 0. So piecewise functions are a type of function where it's split in a different spot.